Hi, everybody. I'm Amy Jaramillo. I'm the scientific director here at Body Science, and we're jumping on today to go over the Astrocyte Protocol. Let me tell you, for motor neuron disease, and here's the reason. I did a video last week. What happened? We have, over the course of the last couple of months, had a number of people with motor neuron disease who have had some impressive results when it comes to voice improvements, so speaking, swallowing, breathing, and mood. It's taken us a while as a center to really understand what's the control switch for those symptoms. And so we had been getting a lot of questions in the form primarily of emails and phone calls. And I'd realized the faster way to reach everybody and put some information out there was a webinar. So I came in, it was last week, I think it was Wednesday, and told my office, let's just put a webinar on today. And that brought up even more questions. So I thought, let me put an appointment out for a week ahead of time to give everybody time that was interested to jump on. And now let's go through in, I think, a little bit more strategic and methodical way. I am well aware that I have a tendency to over science things. When I heard the recording from last week, that's what kind of jumped out. I'm going to try like crazy not to do the same thing today, but cannot make any promises. It seems to be my kryptonite. What I want to do is just give a brief explanation and then answer whatever questions everybody has. So again, what happened, we'd had a number of people who we started a protocol with. It's referred to as the Astrocyte Protocol here at Body Science. And because they posted the improvements, it led to an additional group of questions. I'm sure your question, what is the Astrocyte Protocol? What is going on with breathing, speaking, swallowing, and mood? I would tell you as a center, we don't profess to have all the answers, but I do think we have a pretty clear sense, at least of that side of things. What I would also tell you as a disclaimer, from an FDA point of view, we are not trying to make any claims. We are not suggesting that we are curing ALS. Instead, what I'm looking to do is present the information as we have it anecdotally to give both people that have motor neuron disease more insight and other practitioners that are treating or other centers that are treating to give some insight as well. Here is kind of where this whole process started for me. There has been a question for quite some time, at least on my side, about the link between that group of symptoms. And it started because of Nuedexta. So Nuedexta is an oral medication that can be taken by folks that have motor neuron disease and is oftentimes recommended to improve speech, swallowing, breathing, and mood. The mood component for me made sense. It is ultimately a serotonergic or serotonin driving medication, at least one component, the dextromethorphan component of Nuedexta. The question is, how can you improve a group of symptoms that are not all controlled in the same area of the brain? So meaning the area that's controlling breathing is, of course, very different than the area controlling swallowing versus controlling speaking versus controlling mood, right? So what are we actually looking at? And at that point, it looked less to me like a kind of cell or a location or a nuclei in the brain, and instead more like pathways and potentially neurotransmitters. There has been a lot of discussion about the role of serotonin in motor neuron disease. And I think it's fair to say that most everybody that has motor neuron disease can personally attest to the fact that when you feel sad, angry, depressed, anxious, the sense of unresolved emotions, it oftentimes triggers progression. So in the form of either weakness or fasciculations or general overall progression. We've known that as a center for a long time, and we've known for an overwhelming majority of people with motor neuron disease, they report something really stressful in their life about 1 year up to the time that they develop their first motor neuron symptoms. So my thinking on this whole thing, it's not the cause of the motor neuron disease, but it does look to be involved in the onset or the timing. So at a very emotional event, and then within a year, the onset of motor neuron involvement, putting serotonin back in the middle of this whole thing. And recently, about a year ago, there were a handful of big grants written looking for funding in order to further investigate the role of serotonin in motor neuron disease. The part that's always been confusing, number one, serotonin, is that really the switch I get for mood, but speaking, swallowing, breathing? But also, aside from that, the question is, serotonergics or serotonin driving medications have already been tried. And if it was as simplistic as serotonin equaling voice, then a basic antidepressant, an SSRI or an SNRI, allowing serotonin to stay in the synaptic cleft longer, you would expect to see improvement. And that's not the case as far as lifespan. And so then the question is, if it's not serotonin, meaning if we regulate serotonin levels, we increase them, and that's not the switch, what is the switch and what's controlling the switch? So through that, over time, it became evident that acetylcholine is in that whole picture. Now, in an effort, again, to not over science, let me just say it's a neurotransmitter, and it is what everybody recognizes as fight or flight. So acetylcholine is what you feel, imagine after a car accident, when you come out and your heart is racing, right? And you don't feel hungry and you're like on full alert. Acetylcholine is some burglar shows up in my house in the middle of the night and I wake up startled. Really, that fight or flight response, that is largely the domain of acetylcholine. And what we have found, you can't be both, right? You can't be serotonergically driven, meaning happy, content, feeling good, and in fight or flight. You're one or the other. And between those two, the priority is fight or flight, meaning if a body is in fight or flight, there isn't going to be serotonin. So if, in fact, a burglar breaks into my house, it's not like I'm going to be like, and then start laughing and feeling happy and have them sit down and have a cup of coffee with me, right? Instead, fight or flight is the driver, and I'm not going to make serotonin as long as I'm in fight or flight. There's already been a lot of emphasis looking at the role of acetylcholine as a neurotransmitter in neurodegenerative diseases because acetylcholine is one of the primary signalers to the vagus nerve. And I think there have been plenty of people with motor neuron disease, Alzheimer's, Parkinson's, and MS that have tried external vagus nerve stimulators, but without success. The role of the vagus nerve, it's kind of listening to acetylcholine and deciding, should the body be calm or should the body be in fight or flight? Or to say this differently, sympathetic or parasympathetic nervous system is going to take over. So the sympathetic and sympathetic overdrive refers to somebody that's stuck in fight or flight or is feeling fight or flight. And parasympathetic, by comparison, is kind of a calm, relaxed state. And what we know is routinely people with neurodegenerative disease are trapped in sympathetic overdrive. And so as long as sympathetic nervous system, so fight or flight, is on, remember, it's going to be really difficult to, at the same time, make happiness or make serotonin. What we know is serotonin looks to be protective against motor neuron damage. What we know is fight or flight looks to trigger progression. And so giving you the example from the beginning, anybody that has motor neuron disease that's out there listening, or anybody that's working with or taking care of, loves somebody that has motor neuron disease, you know, you can get into a fight, an argument, feel anxious, feel stressed, feel nervous, have things that feel unresolved, and commonly see almost immediate progression. And for most people, they'll continue to have a progressive episode from that for sometimes upwards of 2 weeks. So the question is, as serotonin decreases, or as acetylcholine takes over, or as sympathetic overdrive kicks in, right? No matter how you want to phrase it or look at it, commonly motor neurons just don't seem to have the protection that they need from serotonin. the idea again of trying to add serotonin or just increase serotonin has been tried, but has not been successful. And so the astrocyte component, taking a step away for a minute from acetylcholine and just kind of positioning astrocytes. Let me first tell you what they are, and then let me tell you the major paradigm shift that we made here at the center, that I made somewhere around October, November. So here's what I thought. I thought motor neurons ultimately became damaged in motor neuron disease. We know the disease is a proteinopathy. So TDP-43 as a protein builds up and limits the ability of the neuron to fire and to survive, limits neuron plasticity. And so the way I looked at this kind of one-dimensionally is this is a disease that's happening in the motor neuron. What changed things for me was the Prime C protocol. So the Prime C protocol is looking at an antibiotic, Cipro, and an anti-inflammatory, I say that cautiously because it really is something different than that, which is celecoxib or Celebrex. And the question, looking at the history of the development of that protocol, what exactly is an antibiotic and an anti-inflammatory treating? Now, there's a couple of pieces to unpack over there. First, that study started with a murine or fish model in 2018, looking at the relationship of both Cipro and Celebrex in combination to reduce the biomarkers or proteins for that are specific to motor neuron disease, and then went into human trials by 2019, 2020, and it was at the end of last year that findings were published looking at the improvements in those biomarkers. So the biomarkers are just measures, typically proteins that are specific for a condition. And so reducing those biomarkers is largely synonymous with getting control of that disease. The question is, what exactly is being treated? Now, here's an interesting thing in the readings. What you'll see is the cell that's being targeted over there is not the motor neuron. Instead, it really is looking at the microglial cells and the potential antibiotic resistant infections in the microglial cells that ultimately prevent motor neurons from getting what they need. Okay, so let me just say this differently. One-dimensionally, I thought this is a motor neuron problem. The question that brought up is, what is the network that the motor neurons are reliant on in order to perform and survive? And so it brings up the question, when a motor neuron is damaged from just wear and tear, who repairs it? When a motor neuron needs more energy in the form of mitochondria, does it make its own mitochondria, or does it require the mitochondria to come from somewhere else? Is it making its own antioxidants? So looking at that protocol, and not at the moment really talking about that protocol from an efficacy standpoint, instead just looking at the fact that it's targeting not so much motor neurons, but the microglial cells. The next question is, the microglial network, what is it really doing? And that's something that's been known for a long time. So the microglia are largely responsible for repairing motor neurons. And so you wonder at that point, is it motor neuron failure as a primary problem, or is it motor neuron failure secondary to, in that case, another group of cells, the microglial cells, that can no longer keep up with the repair? So because that became a question for me, October, November, the next question is, what is the network that really is supporting the motor neurons? Now, I've known it for a long time, the individual structures and cells that support motor neurons, but I hadn't looked at it from that angle. And so now thinking about it, kind of all of us just thinking about it, the motor neurons, of course, have a very, very high demand for energy output and synapsing. How are they getting all of that energy? Where are they getting all the mitochondria? Are they making their own mitochondria? Is that what's happening? Because that in itself is an enormous job. In fact, a cell really could spend all of its time just making mitochondria. And so in the case of the motor neuron, it is largely reliant on astrocytes to make the mitochondria or supplement or support the mitochondria mitochondria are calcium gated, meaning you need calcium to regulate them. Magnesium as well as kind of the partner of calcium to control excitatory and balance excitatory overdrive as well. So astrocytes are critical in making mitochondria for the motor neurons. They're really essential in providing the calcium for those mitochondria to work. They make some of the antioxidants to repair the oxidative damage in the mitochondria. They do all kinds of things. And so the question is, if the astrocytes are damaged, so going back to a protocol where it's focused at not really a motor neuron, but a supporting cell, microglia, if that has an infection, so it can't work, and then you're looking to treat the infection with an antibiotic, and it is not really an anti-inflammatory as much as it is an antifungal, right? Celebrex, it has been known as an antifungal. So if what is really happening is not so much at the motor neuron, but the support for the motor neuron, the repair of the motor neuron, which is largely the microglial cells, then the question is, what happens if the astrocytes get damaged? And the answer is the motor neurons cannot get the mitochondria that they need, right? They can't meet the energy demand. The next question, what are common things that can damage astrocytes? So if common things that can damage microglial cells are infections, by comparison, astrocytes are highly susceptible to certain chemicals, primarily chlorine and fluorine, or perchlorates and perflates. Now, for me, I'd already seen that the second person that I had that got better with motor neuron disease, that's Maris. He'd already put a video out if anybody wants to see his story and his explanation, but Maris had very high levels of polychlorinated biphenyls. So as far as that chemical structure, even as you're thinking about it, polychlorinated, so multiple chlorinated structures on a phenolic ring. The long and short, we knew it. He came in, we tested and saw very, very high levels, as well as a handful of other considerations, specifically viruses. Again, he went to that story online for anybody that wants to see it. Epstein-Barr was a major consideration. We were able to lower those polychlorinated biphenyls. So that's a tough thing to do. And as those levels came down, what we expect is he had improvement. Maris came back recently. So this is about 2 years after going through that process as a full reversal, who earlier last year ran a marathon. Okay, so my only point in saying we know at Body Science there's a role of perchlorates, perflates, so chlorinated, fluorinated compounds, and to a lesser extent, brominated compounds. Okay, so again, the question is, what would damage an astrocyte? And we had already seen clusters of people with motor neuron disease that were living in areas that are known to be high, especially in perchlorates, and even more so perflates. And so then the question was, what if we build a strategy to start improving astrocyte development, astrocyte performance? Then would we see that translate into motor neuron health? Or to say it differently, because we can't test for that, would we see functional improvements? And because the thinking was predicated around serotonin, and serotonin switch is to a certain extent controlled by whether or not you're in fight or flight, then if we can control astrocytes and if we could control acetylcholine, then what we should see is improvements in speaking, swallowing, breathing, and mood. So we started that approach in November. There was a video that went out, which is what led to a lot of the questions. That was Greg, who had really marked improvements and continues to have marked improvements in his voice, in his hand and grip, in his walk. So we saw him in November and we started that protocol. We saw him in December and he continued to have those same improvements. We saw him in January. He continued to have those improvements. And he had sent an email in. We were just talking, I guess it was last week, letting me know that he's continuing to see ongoing improvements. One thing I will throw in, 5 people so far that we've watched show those improvements, 5 out of 5. Out of them, 3, we also worked with stem cells. And so what I would tell you, I'm not sure as a center that we know we're 5 for 5, 2 that didn't have stem cells, and we've seen improvements in all of them. The question is, will we see the same improvements without stem cells? I can't tell, but because all 5 look to show such marked improvements, we're thinking over here that the stem cells may allow improvements to be faster, but are not going to influence ultimately whether or not there's going to be the improvement. As well, we put on a home protocol, which is what a lot of people called about. I'll tell you, at the core, we're talking about mitochondria, one from the astrocytes, and then second of all, once they get into the mitochondria, how do they perform? And we know in motor neuron disease, the mitochondria become devastated, right? And so I think it was Northwestern that put out the pictures of mitochondria in motor neuron disease, and they are so damaged and functionally limited. So the question then becomes, how do we keep the mitochondria healthy? Remember, there's really 2 places that we get concerned about. One, inside the electron transport chain, and then number 2, I get that this sounds obvious now, outside of the electron transport chain. All right, so inside the electron transport chain, that's where all the energy is being made, electrons being liberated by multiple different acids, kind of down a conveyor belt. And that area is very susceptible to oxidative damage because the process of yanking electrons off of acids commonly leaves behind a lot of debris and oxidative agents. So that's an area that we'll look to clean. And if anybody is familiar with superoxide dismutase, that mutation and its relationship to ALS, remember that is an enzyme, you know it because of the ACE at the end, that is dismutasing or removing superoxide radicals. Okay, so to say it differently, people are at high risk if, from a familial standpoint, they have inherited a gene where superoxide dismutase is not properly working. So what that means, if inside the electron transport chain, as free radicals, not just oxides as free radicals, but superoxides, like the worst oxides, are not able to be cleaned up, right? Because the enzyme to dismutase them is not working properly. That's the predisposing risk factor familially, or at least one of them. So we know that we've got to clean up the area inside the electron transport chain. As well, we know that outside the electron transport chain is the cytosol. It's where all the organelles are floating back and forth. It's where the lactate and malate shuttles are going back and forth between the cytosol of the mitochondria and the electron transport chain. It has a lot of free radicals as well. So you're looking at a mitochondria, which is a big engine that's essentially like throwing out gunk and smoke. I don't know if anybody that's on this call lives close to a power factory. Chances are, if you do, you don't want to. And if you don't, you know why, right? It's just like dusty, smoky, dirty. So the mitochondria makes a lot of free radicals because of its job making energy all the time. And so that dusty, dirty, rusty, free radical mess, both inside the electron transport chain and then in the cytosol, for us becomes a major consideration. So it's really kind of a 3-part approach. Number 1, just starting with that, not in any order, cleaning up the mitochondria. Number 2, improving the health of astrocytes. And we have a number of IV therapies that we are trying to focus on that. So meaning from an FDA standpoint, again, we're not making claims that medications do specifically that, although a number of medications have already been documented to improve astrocyte health. So again, I'm not trying to draw a correlation and say there's an on-label application for certain medications. I am saying that things that have been shown in the literature to improve astrocyte health, that's where we focus that attention. And then lastly, looking at the vagus nerve and addressing that sympathetic overdrive from a procedure standpoint. It's that combination, those 3 things. We have, for anybody that's coming in for the Astrocyte Protocol, we have been putting them on that home protocol ahead of time. for people that are not coming in anytime soon, we are still recommending if it looks to be astrocyte related. And so it doesn't mean that voice, speaking, swallowing, rigidity, and mood have to be involved, but that for us is kind of the checkbox of astrocytes. And there's a number of other symptoms that go along with that. But going back to the paradigm shift, before I was looking at the common exposures, infections, and toxins that led to damaged motor neurons. Now I'm still doing the same thing, but grouping those infections as well as the chemicals. So free heavy metals, pesticides, diesel, looking at those things in context with what type of cell would be most vulnerable. Is it the oligodendrocytes and the dysfunction in oligodendrocytes that's associated with motor neuron disease? Is that the cell where, from our vantage point, that's what we're trying to target? And so now taking what was kind of a grouping structure that I was using to understand exposures, and now going a step further and linking them to the certain cells, and then looking for a clinical picture that matches. Meaning microglial involvement looks different than astrocyte involvement, looks different than other cells, including oligodendrocytes. And that, for me, has been a question for a long time. It's nutty, would be my technical term, that motor neuron disease is considered all to be one condition, in spite of the fact that it has such heterogeneity, meaning it looks so different in so many people, right? So how is it the same condition if for one person it's almost exclusively voice for a year, right? And then it moves on. And then for another person, it's right hand, right leg. And for another person, it's bilateral hand involvement. And then somebody else is upper arms and then down two hands. So it doesn't make sense that it could just be this heterogeneity. And from my vantage point, I think most of you know this already, I see this condition as a symptom, right? It's the outcome of a number of culprits that are neurodegenerative. So they are initially neuroinflammatory, and the chronic neuroinflammation ultimately leads to neurodegeneration. Okay, so I think that on my side kind of covers everything. Number one, again, the way that I started with this whole thing is the fact that I could not make sense of speech, swallowing, breathing, mood, and oftentimes increased tone. People that are on lots of baclofen, people that are really rigid when they're walking, that combination kept presenting as a clinical picture. Not always in astrocytes, but commonly. So that was the first question of what's the control switch? Again, it's not a single location in the brain. There is not a nuclei that's going to control that. And then from there, getting to the idea of we know serotonin's involved, there's certainly enough interest in serotonin as it relates to motor neuron disease, and grant proposals to investigate it further. On our side, we'd already looked into that with other serotonergics, including things like methylene blue that can increase serotonin. And the improvements that we saw were very transient by just looking at it through the simplistic lens of serotonin, okay, which created a much bigger picture. And that bigger picture looks to be the mix of acetylcholine, its relationship to astrocytes, the astrocytes' relationship to the mitochondria, and antioxidants and calcium that the motor neurons need. I was still kind of unclear, was I looking at the network that supports motor neurons, or am I still just looking at motor neurons? What clenched it for me was the microglial target of the Prime C protocol. And again, not to oversimplify, meaning it's more than just the microglial cells. And I won't get into it, but we are aware, of course, that Cipro uniquely, or meaning unique to other antibiotics, can increase the TUDCA production, or the conjugation of that bile acid, that taurine-based bile acid. So I recognize, again, it's not so simplistic, but I am trying to not go down the scientific black hole that I can sometimes find myself in and drag everybody else down with. So just from an overview standpoint, again, we know it's looking at a cell that's not really the motor neuron. because of the initial murine model and their findings. And so now the question becomes, again, can we as a center do an even better job of understanding the underlying culprits, getting a better understanding of what those culprits ultimately damage that leads to motor neuron destruction. And I think that's really where we are now. So what I'm going to do is I'll open up questions. I'm not sure if anybody has questions. I'm guessing probably you do. Let me just say. And so if anybody has anything that they want to ask, I'm happy to answer anything for you. I don't see anything yet. So you guys tell me. And if not, then I'm okay if we conclude the call. Okay, I see one vagus nerve procedure. Yes, that's the question. Stellate ganglion or getting to the vagus nerve in the stellate ganglion region. Yeah, it is a way to control sympathetic overdrive, right? That's what it's been used for in the past for indications like post-traumatic stress disorder, depression that's intractable, and anxiety. The way that we kind of got to that as a control switch was, this is probably about 2 years ago, maybe one, that the FDA awarded orphan drug status for the use of ketamine in ALS. And so that was kind of our first look, or my first look, at sympathetic overdrive and the other triggers of that would lead to depression, anxiety, PTSD, and controlling them. I know for some people, microdosing with psilocybin is an approach that they've used. Again, the FDA labeling for ketamine. So it became very obvious that controlling sympathetic overdrive and controlling mood played a major role in neurodegenerative changes. Okay, I can see questions. Exosomes in July, would they still be effective? The thinking on both exosomes and stem cells. So stem cells make exosomes. And so the idea behind them, again, I'm trying to not go down that black hole of science. So senescence or autophagy become the two words that are really important for that conversation, Linda. So autophagy is the cell's ability to remove itself from a population when it's not really working. Senescence is cells that are getting stuck in a population where they don't belong. And so it's been postulated that cells in a senescent phase, it's the root cause of disease, meaning you should replace cells when they're not working any longer, right? Cells divide through mitosis. And when they're not effective any longer, when they don't have enough quality to properly divide and make two healthy cells, when you just have junk because you have old cells, then they're supposed to remove themselves from the population rather than replicating or sticking around. Autophagy is the cornerstone or hallmark when it comes to motor neuron disease. That's why autophagy promoters like trehalose have been used. Although the caveat I would tell you, there are certain infections that can live in the lysosome, and so triggering lysosomal autophagy in people with motor neuron disease that have infections, controlling or using autophagy to their own benefit, those autophagy promoters can actually cause problems regardless. And going back to your question, the objective of stem cells and exosomes, they are still poorly understood, but there is a lot of data now specifically to not just neurodegenerative disease, but ALS. I put a couple of the articles or reference them on our site. And so once they go in, they can do one of two things. Either the first cell, the senescent cell, can rotate out and the new stem cell can rotate in, or what commonly happens instead is the senescent cell will cannibalize the stem cell or the exosome to use the energy and take whatever that cell has. And so, yeah, I mean, once you have those cells, they will do that job. The caveat is, number one, you want to make an environment before you put those cells in. So I know for lots of people, they just have cells put in without doing any pre-treatment. On our side as a center, there's a couple of things that we'll always go through. including an autophagy promotion type of approach. The other thing is the cells are really delicate, so the aftercare becomes really important. There was something else I had in my mind, but I forgot. I'll come back to it. So yeah, Linda, once you put them in, they are going to do the job. I think your real question for me is whether or not adding more cells over time may be a benefit. I would reference the NEURON trial. So that NEURON trial, their specific was 3 injections, about 45 days apart. What we find is at least once every 6 months, if we have an option, maybe even once every 4 months. So that looks to be kind of the approach to stem cells or exosomes. Let me just say. Okay, hang on one sec. I've got to look on the side of the screen. Usually I don't wear glasses because I don't normally need glasses, but because I'm always reading during these, and then last time I couldn't even find my glasses, I thought I'm just going to wear them all the way through. Okay, I said that fluorides cause the astrocytes to fail potentially. How do these get into the body? There are a number of multi-fluorine or multi-chlorine type chemicals. And so they have increased substantially, especially over the last 20 to 30 years as a consequence of industry. And so perflates or multiple fluorinated compounds, or a compound with multiple fluorine attached to them, they're used in Teflon. They're used as lubricants. And so there are areas now where chemicals that have multiple fluorine structures are ubiquitous in the water system. There are a number of areas where well water has been flagged. There are certain areas of the US, there are certain areas around the world that are known to have massive contaminations, almost exclusively from industrial facilities that were close by, perchlorinated compounds, oftentimes on coastal areas because of their use up until the 60s. And from an industrial point of view, fluorinated compounds commonly close to military installations. And so there's already been a big conversation and strong evidence surrounding the fact that people that are using well water may be higher risk for exposures to these kinds of things. And so you just want to make sure that your water is super clean. What I would tell you, I had somebody over here a couple of weeks ago. He had a reverse osmosis that was a whole reverse osmosis system that was put on the house. He lives in farmland and had thought that that would remove pesticides. We did a deep dive to find out that reverse osmosis removes very, very few pesticides. And so I guess what I'm saying is you're looking for fluorine, chlorine structures, common names for perfluorides, PFOAs or PFASs, otherwise known as forever chemicals. As far as brominated structures, we've seen ethyl bromide in well waters. So again, fluorine, chlorine, bromine, those are the 3, and they're halides. They're all in a periodic table. The IDE, so fluorine, fluoride, chlorine, fluoride, bromine, bromide, that's just the negative charge. So to a certain extent, they're interchangeable. So whether you see them as fluorine or fluoride or fluorinated, kind of all the same. And so you're looking to get really, really clean water, because whether it was the person that was here that had pesticide, and then what we found was an increased rate of reactivation of varicella zoster, the shingles virus, that can occur in people exposed to pesticides. There were multiple articles showing the increased risk in farmers for shingles reactivation, and then recognizing in that specific case that we were likely looking at a recent pesticide exposure from a neighbor, and water that got into the well system, and somebody that was stable. We'd worked with him for a period of time now, and he'd been relatively stable for about the last 18 months. And then all of a sudden started showing progression, all to find out it looks to be, we're still waiting for those labs to come back, but it looks to be the spraying that occurred of Grazon that has 2,4-D. and its relationship, not just that, but multiple pesticides that can trigger the reactivation of viruses. So I'm not trying to go everywhere. Again, black hole. Let me control myself over here. But I do think it's useful to know. And so going back to chlorine, fluorine, bromine, make sure your water's clean, and not just for that, but for pesticides and any other agents like heavy metals that have been associated with neurodegenerative disease. I mentioned home protocol, but did not say what it entails. Yeah, hey Deb, I think we're seeing each other sometime soon, but I can ask the office to reach out to you as well. It's dose dependent and lab dependent. We're looking at the mitochondrial function for everybody that we have it on, the Krebs cycle. For people that we don't, we're using kind of general parameters, and for everybody that we do. So we have your mitochondrial Krebs cycle. We'll use that to elaborate dosing. The medical team will determine dosing based on that. Any side effects of the vagus nerve procedure. I mean, you're looking at an anesthetic that's being injected close to the vagus nerve, but you're in the stellate ganglion, meaning that there's other things outside of the vagus nerve that are over there. What's known for vagus nerve, there's almost always going to be redness in the same eye or on the same side as that injection is done. Vagus nerve blocks have been done for a long time. So if you want, you may just want to kind of look it up and get more information. There could be complications, breathing, speaking, swallowing, because the vagus nerve is so involved in that. And so what I would tell you, our way to reduce complications, the approach I've always taken, make sure whomever we're using on our medical side is very qualified and has a tremendous amount of experience. So I believe that a vagus nerve block should only be done by an anesthesiologist. On our side, we're always going to look for somebody that has more than 20 years of experience. I've worked with Dr. Murillo. Let me think about this. I've known him for probably about 15 years. We've worked together in motor neuron disease since 2019. He's the one that does the intrathecal lumbar punctures, and he does ketamine and the sympathetic nerve blocks for us. And so you're always looking at something that I believe is dependent on the person that's doing the procedure. So complication rate for me is largely a result of the person that's doing the procedures. And so we have not had complications. I feel like I should knock on something. But again, I think it's very dependent on who's doing them. So I would tell you the same thing I would tell you with anybody. Just be careful. Make sure that wherever you're going and whoever is working on you has a lot of experience, number one, in the procedure that they're doing, and number two, in motor neuron disease. So whether you're going somewhere for an SOT, whether you're going somewhere for a vagus nerve block, whether you're going somewhere for ketamine, motor neuron disease is a poorly understood condition. I would tell you, I don't think anybody knows what's going on in your brains, right? Because it's just such an unusual condition and that's what we were talking about earlier, not just motor neurons, but so many other ancillary support cellular systems and networks that you really want somebody that has a lot of experience specifically in motor neuron disease. Is it possible to start an astrocyte treatment off clinic? So just know the medications that we use are prescriptions. And so state of Florida, of course, has some very clear regulations, and we're always going to follow them, obviously. And so if there are prescriptions, you must come to the clinic. State of Florida says you've got to walk into the clinic and have an appointment, at least be weighed or measured or something to become a patient. So if you are currently a patient, then that's something that we can evaluate. The medical team will talk to you by Zoom or by phone. If you are not a patient of the clinic, then we cannot prescribe medication. Okay, and then is the protocol temperature sensitive when shipping? Oh, this is somebody that's up in Canada. I mean, you guys are getting some really, really cold weather. And so the medication is stable for shipping, but getting through a snowstorm is something I'm not sure about. If you'd like, you can always reach out to the office. We can take a look at temperature and actually figure out what is going on, I think we're going to have to work with pharmacy and really get clear on what are the guidelines, and then we can give even more information. Is the vagus nerve, so if you're doing a stellate ganglion block, is it permanent? So the way that we started looking at stellate ganglion blocks is because they have been used in the past in neurodegenerative disease and in motor neuron disease in a very limited capacity, meaning there's not a lot of data on it, but there's some data on it. The data from motor neuron does not suggest ongoing need, but the traditional indications, PTSD, depression, anxiety, commonly the blocks are done over more extended periods of time. I can't tell in the literature or the reports for motor neuron disease if it's that they were effective enough and that's why they were stopped, or it's somebody that wasn't able to get to the clinic over extended periods of time. What I would say, the first person that we tracked, right, it's because he was going to be coming back, or expected that he was going to be coming back every month for about 3 months in a row. And so the question is, if he showed improvement in November, what did he look like in December? And interestingly, even better. If he looked good in December, what did he look like in January? And again, interestingly, even better. And it wasn't just voice and breathing, it was moving and hand, I was telling you guys, and less rigidity in legs. The question is, had we not done blocks each month, would we have seen the same? And so last call, there was somebody that was on that we did 2 blocks over a week, and he was on that Zoom call, and the Zoom call was about 2-3 weeks afterwards, and he reported on the Zoom call that he was continuing to see improvements. I don't have an answer, meaning we're so early in. The question is, given the fact that we're early in, why would we share this information? And the answer, as a center, we recognize the limited number of options when it comes to motor neuron disease. And always on our side, we're going to encourage sharing information. I mean, really, I get out there as often as I can to say, hey, this is what we're doing, and this is why we're doing it, and this is what we think is happening behind the scenes. And so I'll have more information as far as the longevity, but what I can report so far, the improvements, and again, impressive, I think. The fact that they've been lasting, but again, keep in mind, we've only been doing this since November, but for the people that we started with, they're continuing to see those improvements. So it's the most I can tell you at this point, and I will keep everybody up to date. As far as the question of does it need to be repeated? Oh, it's the same kind of question. So now you have the answer for that. And I think I've gone through all the questions that are here. Let me just give a quick 5 seconds or so in case there's anything I'm missing and anybody else wants to put a question over there. If not, what I'll look to do is I'll look to publish this video. The last one took longer. I got it up, but there were a couple of video glitches in it. This one, I think, we'll probably be able to post by tonight or tomorrow. That way everybody can take a look again and see if you've got questions. I don't anticipate doing another call on astrocytes, but I will try and get out there more often just to answer these kinds of questions and talk about the types of things that we're doing. And we really have gotten, I think, very good at a categorization system. That looks to be where we're excelling at this point, really understanding the relationships between infections and chemicals, what it looks like from a clinical presentation, which cells or areas of the body are being affected or infected or damaged by those things, and then trying to hone in on then what would this strategy be. And so I think that's really what you're going to hear more about from me in the upcoming couple of months. All right. So with that, there are no more questions. I will sign off for now. It's great seeing everybody. I'm so hoping that this is helpful. And so if there's anything else that you do want to talk about, if there's anything else that you need on our side as far as questions or things that you're thinking about, if you want, you can put them up on the Facebook page, and I'll start looking for them and see if I can't do a Zoom call more routinely to answer them. I'm going to do one shameless plug, so be ready for it. It's not for folks that are on that have motor neuron disease, but it is for you to share with other folks. About a year ago, in combination with Marianne Miller, so Ken Miller's daughter, we decided actually at Ken's behest to start a not-for-profit. And we are really trying to figure out how to defray the cost of treatment, whether it's Body Science or anywhere else, and as well to develop a couple of things. One, a database so we can start putting numbers behind things, and then separate from that, tube feeding formulations, so we can make sure if you're somebody that has a feeding tube that you're getting good quality nutrients. I cannot tell you that those things are coming soon. I can tell you I am aggressively working on them. So the not-for-profit group, it's grown now to about 10 people on the board and in the committees that are working hard to determine where does funding go to and how do we look for people that want to support the needs of people that have motor neuron disease. The commitment I made at the beginning with my husband is that for the first year, we would take on all expenses so that 100% of the proceeds would go to people that had motor neuron disease. That stopped in January. I mean, that was the 1 year, but we've continued. So our thing is to continue on the cost of administration so that that does not take away from any of the donations going directly to people with motor neuron disease. So if you know anybody that wants to support you, what you can confidently say is we are using 100% of those proceeds. And again, our primary focus is whether it's treatment at Body Science or it's treatment somewhere else. We really are trying to take a situation where very few things have coverage. There's only 3 drugs that do, and make sure that there is more availability to the things that look to be potentially beneficial so that people can get better access. So the foundation is the Body Science ALS Foundation. The website is it's bodysciencealsfoundation.org. Again, I know it's a shameless plug, but I just couldn't resist. So for anybody, please tell the folks that you know, the friends that want to help, please let them know. All right. And I sign off now, but I will look forward to seeing everybody again soon. All right. Take care. Be well. I'll see you guys. Bye.